Hello guys, this is Waleed from Flutter Pakistan, and we are finally into the stage where we are going to host our last session for this league, hopefully. And this league ends today, and we are really thankful to all the speakers who participated with us in this whole event, and for everybody who helped out with us, including Saad, including Google developers, including Flutter Karachi team, the designers and all, and marketing people and all of that. So today is the final session, and we have Shakeeb with us, and I'll be introducing him in a few moments. So let's just kick off our final day. Uh, so as usual, I'll be giving a little intro with Flutter. So Flutter is basically it's a literal cross-platform UI toolkit. So it's literal because it has the capability of exposing you to build native apps for mobile, for web, for desktop, for iOS, for Android, for embedded. So that's why I usually call it literal cross-platform. So that's the beauty of Low. So it uses Dart as its basic language, and you can compile natively for all the platforms using one single code base. That's the whole idea behind Flutter. So what is Quizlet? So we had 7 amazing sessions by different speakers, and today we have the 8th. We have the final one. We arranged this whole quiz league because we got an amazing response for the first time when we arranged the quiz, and we didn't do it like we are doing it right now. We did it on Kahoot, and we had some problems there as well. We had some problems communicating with the winners, communicating with the people who participated. So at that time we had a little problem, so we decided to give the Flutter boxes to all of the people who participated in our first event, which went a little crazy, because we ourselves were doing it also the first time. After that, we thought that we had such an amazing response, so we decided to go on with that, with like a complete league and a complete event, and to start for giving this idea. So we have this whole league, and this league consists of 8 sessions. Each session is of half hour, or maybe 35 minutes, depending on the speakers and the timing. And after each talk, we have a 15-minute quiz. And the winners of those quiz will be getting a Flutter box delivered to their home in Pakistan only. So right now we are not capable, and we are not sending the boxes out of the country. So for now we are restricting it to Pakistan only, and we hope that we try to cater the whole world for this in the future. So the rules are simple. You have to see the talk. You have to attend the talk from the beginning till the end, because the questions are all from the talk. So even if you don't know about Flutter, even if you're not familiar with Flutter, or even if you're not familiar with the topic that is being discussed, you can still participate in the quiz and you can still win, because it's all from within the presentation of the speaker. The important thing is that I have been telling people since all the 8 sessions. I have been telling this multiple times. Please don't go for attempting all the right questions. You don't need to attempt all the questions right. You need to attempt it in less possible time. So we have winners who had 6 questions right out of 10, and they did it within a minute or within 40 seconds, and they won. So we had people as well who answered all the questions correct in 5 minutes. So they didn't win, obviously, because the ratio is calculated on the basis of the score, the right answers with respect to the time you have taken. So that is the whole idea. The quiz requires Google sign-in, so we don't recommend you to open the link of the quiz in an incognito window. So you must be signed in already, so that you don't waste precious few seconds of your time. The main thing about this as well is the people who have already won in the previous sessions are not eligible for winning the box again. So you may participate. Yes, of course you can participate, but you won't be eligible for winning the box again, because we have to give the chance to everyone who is participating. So the boxes, will be delivered at the end of the league after this session today. We will be dispatching all of the boxes together of all the 3 sessions that we have in the extended one. So please, this is for everyone who keeps on asking that when we will get the Flutter box. So you will get it at the end of the league, when the league is done. When we have all the addresses, then we dispatch them all together. Today we have Shakeeb. So he's a guy. He's from Fast, and he's working as a research engineer in retro casual. So he approached us and he showed interest in joining Flutter Pakistan and in contributing to the society. So we just thought that we should give chances to people who approach us. So guys, this is for all of you as well. So if you are interested in Flutter, interested in speaking, or just wait. Yeah. So if you guys you are interested in speaking or interested in contributing to the community in any area, so just contact us, and we'll cater you somehow. If we think that you are quite interested and dedicated, so we'll just hop you in. So today Shakeeb will be speaking about async tasks and in Flutter. So this is one really important topic. That's one reason is because this helps you in integrating APIs. So APIs are future, and APIs are they are you ask the backend to give you some data, and it takes some time to return the data. So then we use all these async events and tasks, and which Shakeeb will be explaining us today. So you better listen to this, and it will help you a lot in writing your network calls and all of that. So maybe Shakeeb has some other things as well during this talk, but what I can sense through this topic is you will be easy learning to write some network calls and theory about that. So Shakeeb, without wasting any further time, it's your time to go on, and I'll be just sharing your presentation now.
Okay, thank you, Willis, for the introduction. And so, without further ado, let's delve into the topic. So, my topic is keeping promise.
Yes. I cannot see your presentation.
My presentation is my screen is shared.
Okay, screen is shared. Just wait. Okay, so can anyone comment that if the screen of Shakeeb is visible to you guys? Anyone just comment that if you are able to see Shakeeb's screen. Yes or no? Is everyone able to see this? Somebody saying distortion in voice. Just wait. Let me recheck. You are not able to see screen, right? Yeah. Shakeeb, please share it again, because I was also not being able to share. Just
reshare my
remove
screen.
it. Yep.
Is it visible now?
Yeah. Now it's good. Yep. So Shakeeb, over to you. Thank you so much. And when you are done, just call me back in. Thank you.
Okay. Thank you, Willis, for the introduction. So, without wasting any time, let's delve into the realm of Flutter and future. So, the title of my topic is Keeping Promises in Flutter. This is a little bit on the nose for those of you who are familiar with JavaScript, because if you know JavaScript, you know what promises are. Promises and the term future can be used interchangeably. Flutter uses the term futures for promises. Before I go deeper into promises or futures, I'll have to give you a short background of how Flutter executes its tasks. So, functions are executed.
Your voice is a little, distorted. People are commenting. So can you just move a little closer to your mic? Thank you.
Yeah, let me try and do that. So, so there are two types. A programming language executes its functions in two ways: procedurally and event-based. So what we're usually familiar with is procedural-based function execution. Let's see. Okay, we have this standard C++ code. It has a main function and it has a simple cout print statement. So what happens is when the main starts running, it prints the statement and exit program end. So this is what happens in the procedural language. As many procedures that are defined in the main all get executed one after the other, and once the execution is done, the exit program close. This is not what happens in an event-driven language. Like this is the example from a basic Flutter app, the most basic Flutter app, a Hello World Flutter app. So what happens in this is, okay, once Flutter starts executing the code, it the event loop, which I will explain in much detail later on, the event loop checks what events that I need to execute right away and what I need to carry at a later point in time. The events that it will decide it can carry out at a later point in time, those events are called as futures. More on that later. So let's go deeper into this. So before I go into the event loop, let me tell you what is concurrency and what is parallelism. Because people sometimes confuse them. Okay, they're the same thing. They're not the same thing. In the two diagrams, there are three tasks that are being carried out. One, that in the above diagram, tasks are being carried out concurrently, and in the lower diagram, they're being carried out parallelly. So what the difference is, in the above image, each task is run for a certain amount of time, or in computer language lingo, quanta. After that quanta, the process is paused and another process is given chance for CPU execution, and that is run for a while. And then if the task is complete, then well and good. If it's not complete, then this is paused and the next task in the queue is given chance. Okay, so parallelism. In parallelism, all the tasks that arrive are carried parallelly with each other. They all execute at the same time. So Dart is a programming language that has only one event thread. So there is no actual parallel threads in Dart. Everything has to be.
Excuse me.
Yeah.
Sorry to cut you, but your voice is a little shaky and trembling. So people are complaining that they won't be able to attend the quiz if this is because you're actually I'm also not being able to hear your voice real clear. So it's sort of shivering and trembling the voice the stream. So can you just do one thing that can you do you have any other internet connection your hotspot or 4G because people can wait like for a minute till you switch the internet, so that's better to wait other than like having this and then attending the quiz like in a flea.
Okay. So, Walid, how's my voice right now? Is it clear? Is it non-distorted?
It is clear right now, like the sentence that you spoke was clear, but when you start speaking, so then I guess it distorts.
So should I start?
You just start. If it breaks again, then you need to do something about it because I guess people are complaining a lot. So that's the thing.
Okay, sorry. Okay, so before I explain to you the futures and how the future handling is done in Flutter, we must all understand how function executes occurs in different programming paradigms. The most common programming paradigms are procedural and event-based. So what happens in a procedural event? Procedural programming paradigm. So as you can see, this is the standard C++ code. So it's a simple print statement. What happens is the main reads I have to execute a print statement and it executes the print statement. So in a procedural paradigm, statements are executed on the basis of the declaration on the base or on the basis that they're referenced. They cannot execute out of order. So let's enter with the event-driven paradigm. In the event-driven paradigm, Flutter is an event-driven paradigm. So what happens in Flutter is once the program starts executing, the event loop, which I will explain in much detail later, event loop starts receiving events and it starts seeing the type of the event. If the type of the event is of a future event, it executes the event at a later point in time. And if it's a normal event, it tries to execute the event right there, right then. So as you can see, it creates this code snippet creates a object of the my app class. So it's not declared as a future. So it will see that I have to create this object right now. So it will create this object immediately, and after that it is keep on waiting for new events. If it is a procedural programming paradigm, it would have okay, I'm done with all of my events. Now I need to exit the program. In an event-driven paradigm, it waits for more events to come to the event loop. So before, there's one more thing that I would like to discuss before I tell you about futures. This is concurrency and parallelism. So often people confuse the two as the same. There's a slight difference between the two. In both of these things, the events or the tasks execute out of order. But the small difference is in concurrent tasks, each task is run on the same thread. There is no concept of multi-threading here. So each task is run for a certain period of time, or in computer science lingo, a quanta. After that, the task is paused and a new task is given the CPU. And if the task executes in the allocated quanta, well and good, either it's pause and the next task in the event queue is given the CPU. While in parallel, all of the tasks that can be accommodated at once, all of them are accommodated simultaneously, and all of them execute simultaneously. So this is true parallelism. Concurrency is not true parallelism. Dart is, like many of the JavaScript frameworks that you might know, is a concurrent programming language. It only has one event loop. So we have to be very careful in what we do on the event thread and how we do it. Let's move on. So before moving on to futures, I'm sorry for the delay, but there is one more thing that I would like to discuss, that's isolates and the event loops. So as I've already told you, Flutter does not have the multi-threading properties inherently. What it does have is isolates. Isolates resemble to threads in other programming languages very closely, but there is one major difference. Isolates do it in parallel, but they're independent. In multi-threading, the whole benefit of multi-threading is that all of the threads share the same memory space. What does that mean by sharing the same memory space? All of them can access the same variables. If one thread has access to one variable, the other thread can also have access to the variable. This is not the case with isolates. Isolates, as the name suggests, are isolated from one another. Since they are isolated, so they can not share memory. But what they can share between them is messages. Okay, let's move on. The event loop. The event loop in Flutter or Dart is isolate. It's a separate thread which executes in an isolated manner. Flutter has some technical details why they did not include multi-threading and why they included isolates, but that's a whole different topic for another time. So let me give you a better understanding of the event loop. As you can see on the diagram on the right hand side, there's a gear. The gear is continuously rotating, hence the term loop. The events, like there are certain empty areas on the gear. These are illustrating how many events can it handle simultaneously. So like currently in the diagram we have 3 events. So what happens when an event reaches the execution engine, or in this case, the gear, the event engine will see, okay, bhai, is this event of the type future, or is this a procedural event that I need to execute right now? If it's a procedural event and not marked as a future, it will execute all of the event right now, and this will block your event loop. You might say, what's the problem if the event loop gets blocked? Your entire UI runs on the event loop on a single thread, and now the event loop is blocked by a huge task. So all of the buttons will be irresponsive. Everything on the UI will be irresponsive since the event loop is blocked. So you need to handle these big tasks. Usually these tasks are, as Walid has already said, okay, these tasks are network requests, but these can also be other things like very hard computation that takes a lot of time, like maybe calculating the factorial of 500 or something like that. So now let's move on to futures. So futures in Flutter are actually a data type. So any future, you can make any other data type a future, and you can make any function behave like a future. More on that in the next slides. So whenever you're dealing with a future can be in 3 states of the following. An uncompleted state, when that state is when you declare the future. As soon as you declare a future, it will start executing on the event loop, but will not execute all at once. It will execute concurrently. I'm repeating so that you guys can understand it again. Okay, it will execute the future concurrently, meaning it will execute some parts of the future right now immediately and some parts at a later point in time when the event loop is less crowded. So an uncompleted state, a completed with data state, and a completed with error state. So now, how do you get a future into your Flutter program? Mostly, more often than not, you will see a Flutter being a future. Sorry, mistake. A future being returned to you by a network call. A network call returns a type of future, or if you guys are familiar with shared preferences, that returns a type of future. So since a network request could take a whole lot of time, so it's better that you do not block the entire UI thread while you get the response from the network. It could be like I have a bad network today. It could be something like that, or you're trying to download a huge file. So if you do that on your main thread, that could be like your entire application could freeze or even crash. So how do you handle a future? Once you declare the future, like the first line in which I have declared my future http.get, the future starts executing. So it's in the uncompleted state. So how to receive a value from that future? So any future, any kind of promise, when you the methodology of receiving a value on completion of the future remains the same. You chain the reference of the future with a dot then call. Like here, my future is my reference to my future. So the my future variable is reference to the future whose value I'm trying to get. So I'll change the reference of that future with a dot then call. So futures implicitly, when they're done executing, they pass the response received or the value generated from the future into their then method. And from there onwards, you can manipulate how you want to maybe create a widget out of that or something else, anything. So how do I create a future of my own? This is one example of how we are creating a future. The future class has a number of constructors. Here I am showing you the future.delayed constructor. This is very helpful when you're trying to mock API requests while testing your application while you don't have your backend set up. So what actually happens in this constructor is a future.delayed. It means create a delayed future, and it takes as parameter the duration. Okay, after how much time I need to pass the value into my then call. So here the duration is of 3 seconds. So it will pass the value into my then call after 3 seconds. Let's move on forward. There's one more thing here. Okay, there's a catch error and a dot then. So the dot then, like I've already told you, there are 3 steps to a future. It's going to be a recurring concept. The dot then is the on data parameter, and catch error is the on error parameter of the on error state of the future. Okay, so before moving on forward, like I need to do a task which has 2 futures. Okay, if you think you have a function that it will definitely block your main UI thread. So what you need to do is take the return type of that function, close it in angle brackets, and before angle brackets, you need to mark it as future. Okay, now this is marked as future. Now your event loop knows it does not have to execute the entirety of this function all at once. It can take a breather for a while and see and move on to easier tasks, and when it's free of all the easier tasks, it can move on back to this. But the problem is, if I have 2 functions, 2 future functions, load from disk and fetch network data, the problem arises is that these both are linked together, because I cannot fetch the network data unless I have the ID which comes from the function load from disk. Hence, we enter async and the await keywords. More on this later. First, let me show you how to deal with this if you don't want to use async and await. So, this is the methodology that I've already explained. We have chained the then of the load from disk to the fetch network data call. Okay, once the load from disk is done, then get the value from the load from disk and pass it on to the fetch network data function. And then when the fetch network data function is done executing, it is pass the data from that into the class called process data and return that class from the main function. So as you can see, this is pretty complex to understand if you know wise. This chaining of futures could get really complicated. So Flutter gives you 2 keywords, async and await. Let's see them. So for a brief period of time, forget that the function I'm showing you has the word async in it. So if we were in a procedural paradigm, if functions were to execute one after the other, first we would have written the first statement and then the second statement. So the first statement would have executed the load from disk, which is the first statement. It would have executed completely, returned the value into the ID variable, and then the next statement would have started to execute fetch network data, use the ID generated from load from disk, and then do a network call of sorts. But we do not have that luxury. Both of these functions are marked with the future keyword, meaning what? They can execute out of order. So if these functions execute out of order, your fetch network would be called before your load from disk, which could throw an ugly looking exception at your face. So that's pretty bad. So what we do is use async and await keywords. This is the same function and it executes the one part of it. It's written like a procedural function, but it executes concurrently. Let me try to explain how. When you mark a function with the async keyword, it means that you're going to use the await keyword in the function body, which tells us you cannot use the await keyword without marking the function as async. So what will happen is await, as its name suggests, it will know let if for example if you're at the statement load from disk and before it you have marked await. So what will happen is it will not go to the statement directly below it unless load from disk finishes completely. So it will wait until load from disk, until load from disk completes its execution completely and generates an ID. So same is the case with the next statement, fetch network data. It will not go into the process data or the return statement until it has returned the network data. After that, this is just the process data can be generated procedurally, so no updates required there. But as you can see, the statements execute procedurally, but since the return type of the method is a future, the entire method will not execute procedurally. It will execute some parts of the method will execute in chunks. The entirety of the method, cause it's marked as a future, will not be executed immediately. Some parts of it will be executed immediately. Some parts will be executed at a later point in time. But the await keyword ensures that they do not occur out of order. Okay, I hope that is clear. So this is a bunch of some miscellaneous information, something that I face more often than not. I need to call a function after my widget is done executing. So how do I ensure that it will run exactly after my build method is executes? So there are you could think of using a future.delete, that could work, but that whole depends on how fast your CPU performs and other parameters that like that. So Flutter gives you a callback and add post frame callback. So it executes after your build method executes. So it's a special type of a future function there. If you come across a situation where you need to execute something after your build method is done. Okay, I have one more miscellaneous example, but I will come to that if we have time. Let's see. Okay, that was a brief introduction about futures. Let's go on to stream. So, brief intro on streams. You saw futures. Futures are something that return a response at a later point in time. So, what are streams then? In layman terms, streams are especially streams futures, streams in Flutter, not in other programming paradigms. In other programming paradigms, streams behave a little differently. So, streams in Flutter are a collection of futures. So, the main difference is that futures return a single value, a single future returnable value. Streams can return multiple futures, if that makes any sense. So, how to handle a stream? For example, that you have a stream. Let's say, let's not go into the details on how you will get a stream. So, let's say you have a stream. So, every stream will have two methods, listen and the sync. So, using these two methods, you receive data from your stream and you add data to your stream. So, let's see how you listen to a stream. So, the first statement of this code snippet is a number creator dot stream. It creates a number creator dot object and the dot stream getter returns a stream. So I'll show you how to create this stream in the later slide. But first, let's see how do you listen to a stream. Once you have the stream reference, you can call the listen method. Okay. So once you have the listen method in place, you can every time a new element gets added into your stream, the listen methods gets called. And then you have a data anonymous closure. So that can be used whenever you receive a new data point and on error. If an error occurs, a tidbit about the cancel on error. If one of the newly arriving members, if there's you are trying to create 5 elements in your stream, and like while creating the third element, there is a error occurs, and you have marked cancel on error as true, your entire stream will stop generating numbers. It will not generate the 4th and the 5th number now. But if you have marked it as false, okay, you did not get the third element, but you can move on and get the rest of them. Okay. Now, how to add data to a stream? So like I showed you the listening end of the stream. Now I will show you the adding end of the stream. You need to have a sync. Like we have sinks in our home and we just dump stuff into it and it goes on to the pipe. So it works exactly like that. Like the sink in your home. You dump stuff into it and it comes, the residual stuff comes out the other side. So what happens is that, now let's move, before moving forward, let's see how you get hold of a stream of your own. If you want to create a stream of your own, just use the built-in class called stream controller and define a data type. What will be the generated values, what the data type of the generated values in your stream. Then we have a simple getter of a stream, controller.stream. The controller gives you access to both the sync and the stream ends. So the stream end later on gives you hold of the listen end. So both ends of the stream are controlled by a controller, a stream controller to be precise. So what's happening here is there's a timer periodic. It's a Flutter construct which executes after a fixed interval of time. Like I have defined here 1 second. So after every 1 second, my the operation in the anonymous closure will occur again and again. So and it's a non-terminating stream in this case. But you can have a fixed amount, like you can have a for loop and have that generate futures for you. And once it's whenever it generates a future, add it to a stream. We will see a similar example. So now we are done with understanding brief concepts about future and streams. Now, how will you use them in your code efficiently? Because more often than not, you'll be faced with the dilemma that you have to change your widget, how it looks, or change the date in your widget based upon a network call. So before the network call, your widget needs to look in a certain way, and after network call, it's supposed to look in a different way. So how will you achieve that? So enter asynchronous builders. Usually, if you have been working with builders are procedural. They execute immediately. They render the widgets which are declared in the very immediately. But there are two special types of builder. There is one more which I'm not discussing today, but I will tell you the name at the end of the talk. Okay, the future builder and the stream builder. So these are asynchronous builders. So first of all, let's discuss the future builder. The future builder takes two parameters, the future and the builder. So the scenario could be something like this. Okay, you need to fetch a JSON from the network, and based upon that JSON, you need to update how your widget looks or return or change the widget completely. So what happens is that you have two parameters, the future parameter and the builder parameter. The snapshot parameter which you see, which is passed as a parameter to your builder parameter, okay, is where the data from the once the future executes and returns data, so it stores the data in the snapshot parameter. So your snapshot has a couple of things which are very similar to the future construct. Like I told you, the future has 3 states: the uncompleted state, the has error state, and the on data state. If you look closely, the future builder has the same 3 states. Okay, so what happens is your snapshot awaits your future to return a value, and once the future returns the value, the snapshot value changes, and this builder construct listens for changes in the snapshot state. Whenever the snapshot state changes, the builder method re-executes. So this, here we have defined 3 states for the snapshot. First state is in the if snapshot dot has error. What to do if your snapshot has error? So yeah, the other is else if what if your snapshot has some data, and else if there is no value yet, if your future is in your incomplete states. So as you can see, in all 3 of these things, I have 3 different text widgets. So depending upon how the events turn out, I can supply a relevant widget. One more thing, you guys might be thinking, these features are only for network data. No, they can be for any function which was marked with the future keyword. If a function was marked with the future keyword, you can use it here. But the requirement here is it needs to return something. Because if it does not return something, it will be a void type and it will cause you an error. Because all build methods need to return a widget. Any build method that it may be. Future builder was clear. The other builder I would like to show you is it's a little trickier than the future builder, but it is of massive importance. It does so many things for you. Let me try to tell you for something. Like the future builder had a future and a builder and a snapshot parameter. So similarly here we have a stream, because it will not be a single value but a collection of values. So one more thing before I explain any further, my stream is coming from the cloud Firestore, which is a database service by Google. It so it support and because Flutter is made by Google, so there's great support for that. And so what's basically this line is doing that, it's, you could say there's a table called mountains, a collection to be using the correct lingo, but for everyone a table called mountains, and it's fetching of the entries one by one from that table. Let's just say table for now. So let's say, for example, if your table has 10,000 entries, it will take huge amounts of time. If you could have done this with the future builder as well, but you would have had to first fetch every single mountain actor document. Every entry in Firestore is called a document. So you would have had to fetch all 10,000 documents first, then widget would have started rendering the list view. So if you have such kind of data which can be broken down into small chunks, you should try to execute, because streams are stream responses are difficult to manage on the server side, but it's pretty easy. If you like working with something like Flask or Python, it's easier there too. But if you I'm not sure how easy it's on other programming paradigms. I'm not sure, but it's very easy managing streams with the Firestore. So let me tell you what's happening. The stream returns a collection of mountain instances. So while there is no element in the stream, like meaning the method sync.add hasn't been called even once, it will show the text loading. But as soon as the first element arrives in the stream, what it will do, it will run the map method over the newly arrived member and create a new list type into the list view. So as soon as new members keep arriving in the stream, they will keep being added one by one, not all at once, one by one. So adding one element onto the UI thread will be easier as compared to if you try to add all 10,000 at once. One more cool thing, if you're using the stream builder with the Firestore, it does caching as well. Inherently, you do not need to write any extra code. So this is a perk of using the Firestore with Flutter. Also, one more thing, if there are any changes to your database, Like there was a mountain named Mountain 1 in the database table, and you updated it to like maybe say mountain something. The changes will reflect back onto your mobile screen without you having to code anything explicitly. So that's a pretty cool feature. Let's see. The last thing is it's something called a generator. So generator, as its name says, it generates. So you might think they work like streams or something. They generate something in the future. So you are right and you are wrong. There are two kinds of generators: synchronous generators and asynchronous generators. Synchronous generators generate all of the values immediately. So these are not streams. So, but we have a little construct called asynchronous generators. They generate a collection of data points or collection of features at later points on time. Hence, they create a stream. So these are something that you will not see very oftenly used, but they are used. And you might think from the name they are very tough sounding or difficult. So that's just their name. They're very simple to handle and very simple to implement. I am only explaining asynchronous generators because since our talk is all about futures and stuff, so giving time to synchronous generator does not make sense. So what happens in a synchronous generator, asynchronous generator? You could have any method, and once you're done with the parameter list of the method, mark it as an async star. Once you have done that, you can do two things now. You can mark the return type of your function as a stream now, and you can use the keyword yield. The keyword yield works similarly to the keyword return, but the key difference in both of the keywords are yield and return. Return ends the caller function, the function in which it was called, but yield does not end the caller function, but it does return a value. So a overview would be yield calls the stream dot sync dot add method. The yield adds to the stream a value to the stream. So, but that value can be of a future type. So here we have a function fetch double, which was supposed to double any value you pass for it. This can obviously be done procedurally, but for example purposes, I have marked it as a future. So I'm using it as a weight. So whenever that calculation will be done, maybe it could take like 3 seconds. So after 3 seconds, my function returns a value. Then after 3 seconds, it will be added to the stream. So if you have subscribed to the stream, what do I mean by subscribing to a stream? Whenever you call the dot listen method on a stream, you are subscribing to the stream. So, but you must be thinking, how do I do it with a function and not a stream controller? So it's pretty simple, pretty straightforward. Just call the function, assign it to a variable, and from that variable, call the dot listen method. As simple as that. So I'm done with my talk. Let's go to the topic that I skipped. If you are making something complex and not something pretty same or vanilla like, you will be faced with the task. Okay, if a later point in a time, the state of, like, let's assume there are two widgets, widget 1 and widget 2, and at some later point in time, at a future point in time, the state of widget 1 changes, and based upon that change, you need to update your widget 2 as well. So how will you do that? So Flutter has a pretty neat interface with it for it called the value notifier. Just create a value notifier object and pass it to both of your widgets. Both of your widgets now have the reference to the value notifier. And okay, and in the widgets, call the add listener method on the value notifier. So whenever the state of the value notifier object changes, that method that you called, that you set in the add listener here on val received, it will be called every time the value of the value notifier object changes. So what I'm saying is, one more tidbit, okay, it has to be unique values only. Okay, for like the third statement here is telling you how you can change the value of a value notifier. If you keep assigning it new string, new string, new string, the listener won't be called. It's only called when the new value is different from the previous value. So that's a little bit. So every time new value will be assigned to your value notifier, it will call the on value received method, and based upon that, you can change the state of your widget. So I'm mostly done with all of my topics. So open to questions, or we could move on to the quiz now. Walid, I'm done.
Yep. Thank you so much, Shakeeb. So, guys, actually, this was out of our control regarding the voice lagging and all of the stuff. So, that's sort of same for everyone who was listening. So, I guess whatever you guys were able to hear, or whatever you guys were able to grasp out of this, so for everyone it would be the same. So we won't be, I guess there will be no injustice in during the quiz. So that is for the same for everyone. So now let's we'll just move on to the quiz. Shakeeb, these people were asking that if you can just record this again in your voice with this presentation, like half hour, not this much, like you spoke more than half hour, but like at your home as a screen recording, like people record YouTube videos. So can you just record this whole again, so that we can just upload it somewhere so that people can understand? Because for the quiz purposes, yeah, they will just do something about it, but they were asking that this is a very important topic, so we should be hearing this and grasping this proper. So they are requesting you, so you just, if it's comfortable for you to record it again and give us a video or something like that. That's great. So you can just record it or give it to us, or you can just upload it somewhere and we'll share it to our page later. Thank you. So guys, it's 53 and we are sharing the quiz now. Just wait. Yep. So here's the link of the quiz, and I'm just sharing the screen as well. So the quiz starts now. Thank you, Shakeeb. Yeah, like we can leave this. This will auto end after 15 minutes. Thank you. Thank you so much for your time.